Alright, today we start section 12.3. 12.3 does surface area again, except instead of dealing with our prisms and cylinders, which had two bases to them, we're going to work with our pyramids and our cones instead, which will only have one base. And truly, that will be the one difference in our figure, in our equations to find surface area. And we'll talk about that here when we get later on to the lesson. But as a quick review, it says find the surface area of your rectangular prism. Now, our formula for surface area says you do 2 times the area of the base plus the perimeter of the base times your height. In a prism, as I talked about in 12.2, in a prism, your bases are going to be your non-rectangles. Well, in this scenario, it is the one and only time that you actually don't have any shapes that are not rectangles. So here you actually end up with options. You can use the top and the bottom to be your bases, the left and the right to be your bases, the front and the back to be your bases. Right? Most people choose the front and the back or the top and the bottom. For our sake, we'll do the top and the bottom. So there are my two bases. So it is 2 times the area of that base. Well, that would be 7 times 4. So that's 28. Plus the perimeter of the base. 7 plus 4 plus 7 plus 4 gives us 22. Times the height between the bases. How far is it from the top base to the bottom base? Well, that is 5 inches. So 2 times 28 is 56. 22 times 5 is 110. Add them together, we get 166, and my units would be inches squared. Okay? And that's how you do your surface area of your prisms. Your cylinders would work the same way, just your base would be a circle, and then instead of having a perimeter, you had a circumference. Today we get into shapes that only have one base, such as your pyramid, which is a polyhedron, in which the base is some type of polygon, triangle, rectangle, square, and then those other lateral faces are triangles that all share that common vertex at the top. That vertex, whoops, come on, there we go, nope. That vertex that they are talking about, it is known as the vertex of your pyramid. The common vertex that all of these lateral faces all meet at. Now, what we're going to be working with is a regular pyramid. A regular pyramid is going to be a pyramid that has a regular polygon for the base. So if it has 4 sides, a regular 4-sided shape, that would actually be a square down there. And then the segment joining the vertex to the center of the base is perpendicular to it. So as you come down from that tip point of your pyramid, that vertex of your pyramid, down to connect your base, it is perpendicular to the base, and it is going to be the center of the base, meaning that it will cut your edge length here in half, which is going to be important to us, and we'll talk about why here in a couple minutes. The lateral faces all become what they call congruent isosceles triangles then. Now, the reason we talk about that segment cutting your edge in half is because we actually are not going to want that height for our surface area. Instead, we are going to want what they call the slant height, which is a height coming down this side here, or that face, that triangle. That's the height that's going to be important to us. It is the height of the lateral face of the regular pyramid. Take a look at example 1 then. In example 1, it says a regular square pyramid has a height of 15 centimeters and a base edge length of 16 meters. Find the area of each lateral face of the pyramid. So all they want here is the area of one of these triangles. Area of a triangle, as we hopefully remember from, well, years ago and last chapter, is base times height divided by 2, or 1/2 the base times the height. Now, as far as the measurements go, my base, well, that was 16. The height is actually going to be what we call the slant height of my pyramid. That's the height we need. Now, we don't know what that length is yet. However, we are going to be able to find it. And the way we do so is we are actually going to pull out this right triangle that gets created right here. The height of my pyramid here was 15 meters. The base edge was 16 meters. The key part here is going to be that the height of that pyramid comes down And as I said, it cuts my edge in half. So this length here is going to be half of my edge. So it is actually going to be 8. So I end up with a right triangle right here, where this is 15, this is 8, and my slant height here, which they call that little cursive L, is the height of that triangle. That's my H. That's the piece we want. So it's just Pythagorean theorem. L squared equals 15 squared plus 64 squared. Oops, sorry. Plus 8 squared. 15 squared is 225. 8 squared, 64. Add them together. I have L squared to equal 289. And then we take the square root, and we get L to be 17. So that is that slant height, which is the height of my triangle that they were asking about. So it is 16 times 17 divided by 2. We get 136. Looking at my units, we got centimeters squared. So if you ever need the slant height, that's how you're going to find it. Right? The slant height will be the height that's important to us when we go through and actually start to find surface area. Yesterday, we did our surface area of our prisms and cylinders, and that was the formula for it. 2 times the area of the base plus the perimeter of the base times the height. As far as our pyramids go then, couple changes that are going to be there. First off, in a pyramid, there are no longer 2 bases. There is only 1. So it is just the big B, capital B, area of the base. Plus, we're still going to do the perimeter of the base times our height. The difference is, now all of these lateral faces, they were all triangles. To find the area of a triangle, it was base times height, and then you had to divide it by 2. We're going to do the same thing here. It's perimeter times height divided by 2. That is our new formula. That'll be for pyramids, and when we get to them, cones. But we'll have to make one little change because there's not a perimeter of your base in a cone. Right, so that's going to be our formula then for surface area of a pyramid. Area of the base plus, now they call it 1/2 the perimeter times the slant height. Ooh, did I make that change? I did not. That is my fault. That should not be an H. Remember, perimeter times the actual height we want is known as our slant height. That height coming down the side of your pyramid. Right, so whether you want to call it 1/2 the perimeter times the slant height, or the perimeter times the slant height divided by 2, is up to you. The key, one of the keys, and a mistake people make, look at what gets divided by 2. It is just the right-hand part. Your area of the base stays by itself. It does not get divided by 2. Alright, let's take a look at example 2. Once again, we start off with one of the hardest examples I can give you. Just because the shape of the base is difficult. Here's the hexagon. In example 2, it says find the surface area of our regular hexagonal pyramid. Surface area of a pyramid is area of the base plus perimeter of the base times my slant height divided by 2. Area of the base we'll worry about here in a second. Perimeter of the base, 10 plus 10 plus 10 plus 10 plus 10 plus 10. Slant height, that's the height coming down the actual triangle. Here they actually tell us it. It is 14. So we have the right-hand piece. Now we just need the area of our base. Your base is a regular hexagon. So it is apothem times perimeter divided by 2. Your apothem, they actually give it to you. It is 5 square roots of 3. Your perimeter we've already established is, oh my gosh, 60, which I just realized I made a mistake. Sorry about that. I'll change it here in a second. 5 square roots of 3 times 60 divided by 2. So 5 times the square root of 3 times 60 divided by 2 is 259.81. So that was the area of our base then. Now, I know I said to find the perimeter of the base. You add up all those sides, 10 plus 10 plus 10 plus 10 plus 10. I didn't write it down that way though. I only wrote down our 10. This was the perimeter of our base. This was our P. That perimeter of our base then should be 10, 20, 30, 40, 50, 60. So it's 259.81 plus that 60 times 14 divided by 2. 259.81 times 14. We get 679.81. Looking at your units, it is feet squared. Alright, moving on from our pyramids, you also have your cones. It's truly going to be the exact same thing. Right? The only difference is going to be there is no longer going to be a perimeter of your base. It is going to be known as your circumference. A cone is a figure with a circular base and then a vertex that is not in the same plane as your base. That vertex they're referring to, that's your tip point of the cone. A right cone, just like a right pyramid, means I'm going to come down. That vertex is going to come down and be perpendicular to the base. And it will also come right down in the middle of that base. Meaning, if I had the diameter, if I took half of it, I'll get my radius. Now, your lateral surface, as a reminder from 12.2, essentially means that we have no base. Well, in a cone, it's kind of weird because there's not a shape there now. So it's just all these segments that come down and join the vertex to all the points that are on that circle. All of those segments combined make your lateral surface. Essentially, it's the fact that there's no base. As far as your actual formula goes, as we talked about, the only difference is going to be, instead of there being a perimeter of your base, it's now called your circumference. Now, you don't have to worry about this second part here if you don't want to. All they did is write down your formulas for you to remember for area, and then they took your circumference formula and then simplified it down because of that 1/2 that was there. Let's take a look at example 3. It says, what is the surface area of the right cone? Now, notice this is a multiple choice question. So, all of my choices have the pi in there. So we need to leave our answer in terms of pi. So it is area of the base plus the perimeter, there's no perimeter in a circle, plus the circumference of the base times the slant height divided by 2. Area of the base, your base is a circle with a radius of 6. So it is pi times 6 squared plus the circumference of your base. Circumference is 2 times pi times your radius, which again was 6. Times our slant height. Our slant height here we do not know. So, if we don't know it, it's just a quick right triangle to do. I have x squared equals 6 squared plus 8 squared. So, x squared equals 36 plus 64. Add them together, I have x squared equals 100. Take the square root, we get x to equal 10. Now, here's the key. When we go to do these, we want to leave our answer in terms of pi. Because in our choices, all of our choices actually have pi in the choice. So, 6 squared times pi is going to be 36 pi. Plus 2 times 6 is 12, times 10 is 120, divided by 2 is 60. So I have 60 pi. 36 pi plus 60 pi gives me 96 pi. So looking at my choices, it is choice B. Right, and that's how we work with surface area. Take a look at example 4 then. It says, the size of a traffic cone can be approximated to find the radius, or can be approximated to have a radius of 5.7 inches and a height of 18 inches. So I have a radius here that is 5.7. I have a height that is 18 inches. It says find the approximate lateral area. Now, lateral area, remember, means no base. So if my surface area formula was this, Lateral area does not want a base. So we get rid of the base. So it is just circumference times slant height divided by 2. Circumference is 2 times pi times the radius, which is 5.7, times the slant height. Now, slant height, that's this height coming down here. We don't have it, so we find it. X squared equals 18 squared plus 5.7 squared. 18 squared is 324. 5.7 squared is 32.49. Add them together. We get 356.49, and then I want to take the square root of that answer. So we get our x to be 18.88. So there's our slant height then. So 2 times pi times 5.7 is our circumference, times that slant height of 18.88 divided by 2. Sorry, I'm working with a different calculator than I'm used to. My daughter took mine. So we have that times we get 338.09. Looking at my units, everything was in inches. So surface area says we have inches squared. Alright, last thing in example 5 here. For A, it says find your lateral area again of our right cone. Lateral area just does our circumference times the slant height divided by 2. Circumference is 2 times pi times your radius, which is 15. Slant height, once again, we have to find. So pull out your right triangle. 20, 15, x squared equals 15 squared plus 20 squared. X squared equals 15 squared is 225. 20 squared is 400. Add them together, I have x squared equals 625. So x equals 25. So there's your slant height then. So is your circumference was 2 times pi times 15 times your slant height, which was we just found to be 25, divided by 2. So pi times, so we get 1,178.1. Now, second one then wants you to find your surface area. Surface area, we now add that base in. Area of the base times plus the circumference times slant height divided by 2. Well, that circumference times slant height divided by 2 we've already found, 1,178.1. We need the area of our base then. So it is pi times 15 squared. We get 706.86 plus our 1,178.1. Add them together, you get 1,884.9. Whoa. What was that? That was a different shape. 0.96. I'm sorry, 97? Yeah, 97. And units are in yards this time, so it is yards squared. Alright, that finishes up 12.3. If you have questions on surface area, please make sure you email me. Let me know. I'll go over anything you want. Next up will be volume that we'll get to here. So, here's your homework, 814 to 815, numbers 3 to 23, the odds only. And once again, any questions you have, please don't hesitate to email me. All right. Stay safe, everyone.